In this video, we're going to look at a few select questions from your final exam review. And we're going to start with question number 4, which says the line y equals 5 is a horizontal asymptote to the graph of which of the following functions? Now, if you remember, horizontal asymptote means the limit as x goes to infinity of whatever the function is. And whenever that function is a rational expression, we talked in class about how the numerator and the denominator, if they were both going to infinity, if they were racing there, which one would get there the fastest? And if it's the top function, then there is no horizontal asymptote. If the top function wins, that means that the limit's going to infinity. If it's the bottom function, the denominator function that wins, then that means that the horizontal asymptote is at 0. And if the numerator and denominator are both the same type of function, if they tie in the race, then they're going to cancel each other out and we'll be left with the exponents. So answer choice A, we've got sine of 5x on the top, and that function doesn't even go to infinity. Sine of 5x just oscillates between 1 and -1. And my denominator goes to infinity, but since they're not both going to infinity, then this is not the answer. In fact, the limit as x goes to infinity on A would just be 0. For answer B, y equals 5x, if x goes to infinity, that function goes to infinity, so that is not the answer. On C, if x goes to infinity, for that one, limit as x goes to infinity of this one is 0 because the denominator gets really, really big. On answer D, this time in the numerator and denominator, they are both linear functions, which means they're going to tie in the race to infinity, and we'll be left with the coefficients, which in this case is 5 over -1, which gives us -5. And so finally, looks like the answer is going to be E. When we get down here to answer E, notice that on the numerator and the denominator we have an x squared function. They're both x squared, which means they're going to tie in the race, cancel out, and we'll be left with 20 over 4, which does indeed equal 5. And so E is the correct answer. All right, next question, we're looking at number 18, and in this question, we were given 3 different graphs and asked to determine which graph is F, which graph is F prime, which graph is F double prime. There's some different ways that you can go about this. One thing, though, I hope that we would think about our chart to start with. So if I have F, F prime, and F double prime, and I'm just going to do kind of a shortcut version of the chart. So we have those relationships between F, F prime, and F double prime. What I haven't included there on the chart are the relative max and mins, the points of inflection. And if we think about those things, that is one way to approach this by looking at the zeros. I notice on this first graph, I've got a 0 right here before 1 and another 0 right in there around 3. And at the one that's located right before 1, we're changing from positive to negative, which would indicate a relative min if this function was a derivative. And then the one that's right there at 3, we're going to from negative to positive, which indicates a relative max on another function if this was a derivative. And I notice on graph number 3 that I do have a max right there before 1. I do have a min right there around 3. And so it looks like graph 3 is, I'm sorry, let me back up. It looks like graph 1 is the derivative of graph 3. And so that means that graph 3 could be F and graph 1 could be f prime. Or if we figure out that graph 3 is actually f prime, that would make graph 1 f double prime. So for now I'm going to have them labeled f and f prime, and then we'll see if we can figure out how graph number 2 fits into this relationship. Now we can also check increasing and decreasing. I notice on f, if this is f, that this graph is increasing first, and what we have labeled as f prime right now is definitely positive. And then between that max and min, the graph is decreasing, and our f prime graph is negative for that whole time. And then finally this graph is increasing, and what we have labeled as f prime right now is positive. So certainly seems like 1 is the derivative of 3. Now we just need to figure out the relationship of 2. So if I look at 2, I'll just check the 0 to start with. I've got a 0 right here between 2 and 3, changing from positive to negative, which would indicate a relative max on if this was a derivative on its preceding function. And if I look at my other 2 functions, neither one of them have a relative max between 2 and 3. And so that doesn't seem to be, seems like maybe 2 is not a derivative graph and might in fact be the f graph. If that's the case, if this is f, and I'll put a question mark for now, if this is f, then we would hope that graph 3 would be f prime, because we think graph 1 is the derivative of f, and that would make graph 1 f double prime. So if we look at graph 3, let me grab a different color here. I'm going to check the zeros on graph 3. I've got a 0 just here after 1, and I've got a 0 over here right before 5. Here right after 1, we're changing from positive to negative, which would indicate a relative max on f, and at the 1 right before 5, we're going from negative to positive, which would indicate a relative min. If I go over here and look at graph number 2, right there after 1, we do have a relative max, and just before 5, we do have a relative min, and I missed one in fact. Here at 0, we're going from negative to positive, which would indicate a relative min, which we also have here. And so then graph 3 is the derivative of graph 2. So I'm going to go ahead and erase our question mark. That means this graph is f. Graph 3 is f's derivative, so it's f prime, and that makes graph 1 f double prime. And so the answer choice that has those numbers in the correct order is answer choice C. All right, question number 22. We have this graph of f that's given to us, and the information that f of x is equal to the integral from 2 to x of g of t. And it's asking us to choose the graph of g. So what's important here is the relationship between f and g. That's what we have to figure out. If f is the integral of g, then I could set up a relation chart, say this is g, and f is the integral of g, so I'm going up because it's an integral. And so what that means, if f is the integral of g, that means g is the derivative of f. If f is the integral of g, g is the derivative of f. And we're looking for g. If this is the graph of f that we're given, it's a line, which means the graph of g is going to be the derivative of that graph, or the slope of that graph, which should just be a constant function because lines have constant slope. This line is increasing, and so my g graph should be a constant positive number, something like this, which corresponds to answer A. All right, moving on to question number 23. In this question, we're asked to determine an expression for average velocity. Particle moves along the x-axis. The velocity is given by v of t, and the acceleration is given by a of t. And it says which of the following gives us average velocity. Now, if you think about our discussions in class about average things, we've got two formulas for averages. One of them is average rate of change. One of them is average value. All right, average rate of change and average value. And if I want average velocity using the average rate of change formula, velocity is the rate of change of position. In fact, let me go down here and remind us of our relationships. Position, velocity, and acceleration, or PVA. This is our relationship. Remember, down with derivatives, up with integrals, and the rate of change means slope, which means derivative. And so the velocity is the derivative of position, or the rate of change of position. It's down a level from position. And so if I'm going to use average rate of change to find average velocity, then I need to know a position function, which in this case would be, my position would be x of t, because they said we're moving on the x-axis. And so average rate of change would be x of b minus x of a over b minus a. And that would give us average velocity, because it's the rate of change of position. Now, if I wanted to use the average value formula, average value means that I'm averaging whatever the function represents. And so in this case, if I want average velocity, then I need to have a velocity function if I'm going to use the average value formula. And so average value formula for average velocity would be the integral from a to b of v of t dt. That part sums up all the velocities, and then when we multiply by 1 over b minus a in the front, like dividing by b minus a, and this is going to give us average velocity. So if you look at our answer choices, I don't see any of the answer choices that look like the average rate of change formula, but I do see on answer B that's going to give us average value of velocity from time 0 to 8. And so our correct answer choice here would be answer B.